in section 1.5, we learned how to manipulate and simplify various algebraic expressions. Okay, that's what this focuses on. Right? Simplifying and manipulating algebraic expressions. And so in doing that, we're going to be utilizing occasionally, right, these formulas up here. And again, there's no formula sheet on exam. So on exam 1, these formulas have to be up here. But they're not that difficult to memorize because in mathematics there's lots of patterns, and all you got to do is remember the pattern. Okay, that's one reason I think that I was able to succeed in math was I could always see patterns in things, and the patterns, remembering the patterns made it easy to do the math. Okay. And we'll talk about that before the exam, what patterns I see in these formulas. Okay. And so in the first rational expression that we have to simplify, we have 24x squared minus 14x minus 3 over 4x minus 3. So to see if we can simplify this expression, right, we're going to factor the numerator. And so this is a quadratic, and it so happens we can factor that numerator with using integers. Okay. 24x squared minus 14x minus 3 factors into 4x minus 3 times 6x plus 1, and then the denominator we have 4x minus 3. Well, you can see 4x minus 3 is a common factor in the numerator and denominator, so they cancel, okay, and we're just left with 6x plus 1. Now, you don't have to add this next little bit, but eventually this semester we're going to be talking about the domain of a function. And so if our function f of x is equal to this rational expression, right, there's a certain value of x that makes the denominator equal to 0. And you know you can never divide by 0. Okay. What value of x makes the denominator equal to 0 over here? Can you tell? Well, if I set 4x minus 3 equal to 0 and solve for x, I get x is equal to 3/4. So if I put 3/4 in for x here, we have 4 times 3/4 minus 3, and that's equal to 0. And you can never divide by 0 in mathematics. Okay. So this rational expression reduces to 6x plus 1 as long as x does not equal 3/4. If x is equal to 3/4, we're going to end up with 0 divided by 0, which is undefined. Okay. So this rational expression equals 6x plus 1 as long as x doesn't equal 3/4. Okay. You don't have to write this down, but I'm trying to prepare you for the concept of the domain of a function in chapter 2. Okay. All right. In the next example, we have to simplify x plus 1 cubed plus x minus 1 cubed over x. Now, 1 cubed is a binomial expansion with a equal to x and b is equal to 1. And x minus 1 cubed is a binomial expansion with a equal to x and b equals 1. So those binomial expansions, so if we use the plus sign, we have a plus b cubed is equal to a cubed plus 3 times ab squared plus 3, I did that wrong, a squared b plus 3 times ab squared plus b cubed. So this binomial expansion for n equals 3, right? We use the plus sign here, a plus b, and we're going to use the plus sign over here on the right-hand side. Okay. And then if we have the binomial expansion a minus b cubed, we have, that's equal to a cubed. These two plus signs get changed to minus, and we have a cubed minus 3a squared b plus 3 times ab squared minus b cubed. So you'll notice there's a pattern, right? There's a similarity between those two. And so once you see the pattern between those two, right, it makes it easier to remember. Well, in our example over here, right, we have, this is a binomial expansion of degree, right, of n equals 3. This is a binomial expansion of n equals 3. And each of these, the a from over here is equal to x, right? Replace a with x, and we replace b with 1. Okay? So in x plus 1 cubed, replace a with x and b with 1. And with x minus 1 cubed, replace a with x and b with 1. Okay? Just substitute for a and b on the right-hand side. So, x plus 1 cubed, using this binomial expansion for x plus 1 cubed, we have x cubed plus 3x squared, right? b is equal to 1, so when I put in x, x for a here, I have x cubed. When I put in x for a here, and 1 for b here, right, I have 3 times x squared times 1, which is just 3 times x squared. Then we have 3 times x. Then we have plus 1 cubed, which is just 1. And now we got to add to that x minus 1 cubed. And so we put in x for a down here and 1 for b down here. And when we do that, we have plus x cubed minus 3x squared plus 3x minus 1. When I replace a with x and b with 1 over there. Okay. In the denominator we have x. Well, simplify the numerator, right? Combine like terms. 3x squared minus 3x squared is 0. And plus 1 minus 1 is 0. And so we're left with x cubed plus x cubed is 2x cubed. And 3x plus 3x is 6x. All divided by x. Are you sure you wouldn't rather sit over here? Is it going to be hard to see?
No, it's going to be good. I can see it.
All the way down to the bottom?
Yes, just.
Yeah. So we can continue to simplify. In the numerator, we have a sum of two terms. Each term includes the variable x. So we can factor out an x, okay? The lowest power of x is x to the first, so we can factor out an x. The coefficients 2 and 6 are both divisible by 2, so we can factor out a 2. So we can factor out a 2 times x. You have 2 times x squared plus 3. Actually, I'm going to write it to the right of here. 2 times x plus 3, right? I can factor out a 2 from those two terms, and I can factor out an x from those two terms. Excuse me, this should be x squared plus 3. Divided by x. But now you can see x is a common factor in the numerator and denominator. So the x's cancel. And we're just left with 2 times x squared plus 3. So this rational expression here simplifies to 2 times x squared plus 3, okay? As long as x doesn't equal 0. Because if x is equal to 0 over here, we're dividing by 0. We can't divide by 0. So x can equal 0. Any questions on that? All right. In the next example, we have a sum and difference of quotients involving the variable x. We have to simplify. Well, when you add and subtract fractions, what do you need? The common denominator, okay? So let's see. We know x plus 2, 2x minus 1. Adding those two fractions, we would have to multiply x plus 2 times 2x minus 1 to get a common denominator. So let's see what happens when we multiply those two. X plus 2 times 2x minus 1. Right, got a FOIL. When you multiply first terms, we have x times 2x, which is 2x squared. When you multiply outer terms, we have x times minus 1, which is minus x. When you multiply inner terms, you have 2 times 2x, which is 4x. And when you multiply last terms, you have 2 times minus 1, which is minus 2. FOIL. Okay, F-O-I-L. And now when you simplify like terms, minus x plus 4x is 3x. So it turns out the product of these two denominators is equal to this denominator. So our common denominator is x plus 2 times 2x minus 1 equal to 2x squared plus 3x minus 2.
this denominator factors into x plus 2 times 2x minus 1. And so to rewrite this quotient with the common denominator, we have to multiply top and bottom by 2x minus 1. So we have minus 4 times 2x minus 1 times x plus 2 times 2x minus 1. And now, to write this third quotient of the common denominator, we have to multiply top and bottom by x plus 2. And so we have 8 times x plus 2 over x plus 2 times 2x minus 1. So x plus 2, right, is now factored in the numerator and denominator for that third quotient. Well, now we have a sum and difference of 3 fractions or 3 quotients with the same denominator. So now we can combine the numerators over the common denominator. So we have 10x minus 4 times 2x minus 1 plus 8 times x plus 2 over the common denominator x plus 2 times 2x minus 1. Now I gotta simplify the numerator. So we gotta distribute the minus 4 inside the parentheses here and plus 8 inside the parentheses here. And so when we do that, when we distribute the minus 4 inside parentheses here, we have minus 4 times 2x is minus 8x. And minus 4 times minus 1 is plus 4. Then when we strip the 8 inside parentheses here, 8 times x is 8x. And then 8 times 2 is 16. And that's all over the common denominator. X plus 2 times 2x minus 1. And now I'm simplifying the numerator. Combine like terms. You do 10x minus 8x plus 8x. The minus 8x and the plus 8x cancel. And we're left with 10x. And then 4 plus 16 is 20. And that's all over x plus 2 times 2x minus 1. Well, in the numerator, you got 2 terms. 20 is divisible by 10, so we can factor out a 10 in the numerator. And we have 10 times x plus 2 over x plus 2 times 2x minus 1. 10x plus 20, right? You can factor out a 10, and you're left with 10 times x plus 2. Well, now you can see x plus 2 is a common factor in the numerator and denominator. They cancel, and we're left with 10 over 2x minus 1. So this sum and difference of three quotients simplifies to 10 over 2x minus 1, provided x doesn't equal two numbers. What two numbers will make the denominator over there, if any of those quotients equal to 0? Yeah, -2, so x can equal -2, and it can equal 1/2. It's -2 put in here, makes this denominator equal to 0, and 1/2 put in for x here makes this denominator. Any questions on that? Okay. So flip over your page. So this one at the top of the page, we're going to simplify rational expression that's quadratic in the numerator, quadratic in the denominator. So we have x squared plus x minus 6 over x squared minus 5x plus 6. So let's see if those either of those quadratics factor with integers. All quadratics factor, but they may not factor with integers. Okay. Later on semester, we're going to be factoring some quadratics with square roots and stuff, and complex numbers even. So this first guy, does anybody know what x squared plus x minus 6 factors into? X plus 3 times x minus 2. What about the bottom? Say that again, please. Yeah, x minus 3. X minus 2. So now you can see x minus 2 is a common factor in the numerator and denominator. And we're left with x plus 3 over x minus 3. And this rational expression simplifies to this under the condition that x doesn't equal what number? Yeah, positive 2. Positive 2 makes the denominator equal to 0. All right, in the next example, we have x squared minus 4 over x cubed plus 8. Well, x squared minus 4 is a difference of squares. And so we have the formula at the top of page 1 for the difference of squares. It's the first formula. Okay. But this is just a quadratic, and it factors into x minus 2 times x plus 2. When you FOIL over here, you don't get a term involving just x, the middle terms. Now down here we have x cubed plus 8. This is actually a sum of cubes. That's x cubed plus 2 cubed. Okay. 2 cubed is equal to 8. And so in the formula for a cubed plus b cubed, A is equal to X, and B is equal to 2. So A cubed plus B cubed is the sum of 2 cubes. That's the third formula. It's the top of page 1. So this factors x cubed plus 8 factors into x plus 2 times x squared minus 2x plus 4. And so if you were to use the distributive property and multiply this out, you would end up with x cubed plus 8. And you can see that x plus 2 is a common factor in numerator and denominator. And we're left with x minus 2 in the numerator over x squared minus 2x plus 4 in the denominator. And so this, what we started with, simplifies to what's in the rectangle under what condition? X can equal what? Negative 2. Because you put in negative 2 for x in the denominator equals 2. Okay. Any questions on that? Next we have 5 minus 5 times h plus 1 squared over h. One of the reasons that we're doing this is, a lot of you got to take Calc 1, and in calculus you got to do a lot of algebra sometimes before you get to the calculus, right? So it's important to have these types of scales. All right, so in simplifying this, instead of x being our variable, h is our variable. First thing we got to do is FOIL h plus 1 squared, right? And so over here on the side, h plus 1 squared is just h plus 1 times h plus 1. And so when you FOIL that, right, you get h times h, which is h squared. And when we do the outer terms, you have h times 1, which is h. When you do the inner terms, you have 1 times h, which is h. And when you do the last terms, you have 1 times 1, which is 1. F O I L. And so that simplifies to h squared times 2h plus 1. So over here in the numerator, we have 5 minus 5 times h squared plus 2h plus 1. Let me riddle me this. Why did I FOIL h plus 1 squared and not just do 5 minus 5 first? Order of operations, right? PEMDAS, right? Exponentiation, right, comes first. Yeah. And so again over here, the reason I don't do 5 minus 5 first is because multiplication, this is minus 5 times what's inside parentheses. So you got to do the multiplication before you do the subtraction. So we're going to distribute the minus 5 inside the parentheses. We're going to use the distributive property. So we have minus 5 times h squared is minus 5h squared minus 5 times 2h is minus 10h, and minus 5 times plus 1 is minus 5. Well, simplify the numerator, 5 minus 5 is 0. And we're left with minus 5h squared minus 10h in the numerator over h in the denominator. So in the numerator, we have two terms. H is in each term. And so we can factor out a power of h. So in the first term, it's h squared. In the second term, it's h. So the smallest power of h is 1. So we can factor out an h in the numerator. And then minus 5 and minus 10 are both divisible by minus 5. So we can factor out a minus 5. So now we can factor out a minus 5 times h in the numerator. So we have minus 5 times h. And when we factor that out, we're left with h plus 2 in the numerator over h in the denominator. And now you can see h is a common factor in the numerator and denominator. Cancel. And we're left with minus 5 times h plus 2. So our original expression, rational expression, simplifies to this in the rectangle, provided h doesn't equal what? What h can equal? 0, right? Put in 0 for h here, and you get 0 in the denominator. Any questions on that? All right. In the next few problems, we're going to rationalize either the numerator or denominator. And many of you probably in high school had to like rationalize a real number that had square root in the denominator. Right? If you had 1 over the square root of 5 is your answer, you had to rationalize that, get rid of the square root in the denominator. What did you do to get rid of the square root in the denominator? You multiplied top and bottom by square root of 5, right? And so when you do that, 1 times the square root of 5 over square root of 5 times square root of 5 in the denominator. Numerator 1 times square root of 5 is square root of 5. Denominator square root of 5 times square root of 5 is 5. So 1 over square root of 5 and square root of 5 over 5 are the same number on the real number line, right? They have the same magnitude. Use your calculator to get a decimal answer for each of these. You get the same decimal answer. So in solving these problems, on the next few problems, we're either going to be rationalize the numerator or the denominator. Either getting rid of the square root in the numerator or getting rid of the square root in the denominator. And again, the reason why we got to do that is in calculus, before you can do the calculus, you got to do the algebra. So let's define a couple of concepts. One is, let's define what we mean by the conjugate of a number. So we have this A and B are real numbers. Okay? So A and B are two real numbers that we're at. The conjugate of A plus B is A minus B. Right? All we do is change the plus sign to a minus sign. The conjugate of A minus B is A plus B. All we do is change the minus sign to a plus sign. And the reason for that is, in rationalizing these algebraic expressions, we're going to be multiplying top and bottom by the conjugate of, in this case, the numerator, right, involving the square root. And when we do that, when we multiply A plus B times its conjugate, we create a difference of squares. When you FOIL this, you get A squared minus B squared. And that enables us to get rid of the square root, either in the numerator or the denominator. Okay. So let's demonstrate that with this first example. You have the square root of x minus 4 over x minus 16. So we got to rationalize the numerator, get rid of the square root in the numerator. So to do that, we're going to multiply top and bottom by the conjugate of the numerator. And the conjugate of the numerator, we just change the minus to plus. And we're going to multiply top and bottom by square root of x plus 4. So we have the square root of x minus 4 times the square root of x plus 4 in the numerator, and x minus 16 times the square root of x plus 4 in the denominator. So the conjugate of square root of x minus 4 is the square root of x plus 4. That's what we multiply top and bottom by. And now when we FOIL the numerator, we're going to create a difference of squares. Okay. A in this case, right, this is like A minus B times A plus B, right? I wrote it backwards over here, right? Because I wrote this as A minus B times A plus B is equal to A squared minus B squared, right? Switching the order of the two factors. So this numerator simplifies to the square root of x squared minus 4 squared. A is equal to square root of x in this case. B is equal to 4. And so that product is equal to A squared minus B squared, which is square root of x squared minus 4 squared, over x minus 16 times the square root of x plus 4. Well, square root of x squared is equal to what? Just x, right? Square root of x times square root of x is x. And 4 squared is 16. See a common factor in numerator and denominator? X minus 16. So this is equal to 1 over square root of x plus 4. No square root in the numerator, right? Now we do have one in the denominator, okay? But we don't have one in the numerator. Okay? What can't x equal in this case? Original expression. What makes the denominator, what value of x makes the denominator equal to 0? Somebody, anybody. Can you tell? Yeah, 16. Shout it out. Don't be bashful. Okay? You guys are a very reserved class. I've had other classes where they're shouting, everybody's shouting it out the answer. Okay? Yeah. You put in 16 for x here. You got 16 minus 16, which is 0, and you're dividing by 0. You can't divide by 0. Okay? All right. Any questions on that? All right, so let's take a look at the next one. So, same pattern. You gotta get rid of the square root of the numerator. So what are we gonna multiply top and bottom by? The conjugate of the numerator, right? What's the conjugate of the numerator? Change the minus to a plus, right? There's gonna be 2 plus the square root of x plus 3. So you have 2 minus square root of x plus 3 times 2 plus square root of x plus 3 over x minus 1 times 2 times the square root of x plus 3. Right? So the conjugate of 2 minus the square root of x plus 3 is 2 plus square root of x plus 3. That's what we multiply top and bottom by. Well, so the numerator is like a minus b times a plus b, right? Where a is equal to 2 and b is equal to square root of x plus 3. And a minus b times a plus b is a squared minus b squared. Difference of squares. So a squared in this case is 2 squared. And b squared in this case is square root of x plus 3 squared. And that's all over x minus 1 times 2 plus the square root of x plus 3. So now we simplify the numerator. 2 squared is 4. And squaring does square root. And we're left with x plus 3, right? Square root of x plus 3 squared is just x plus 3. But the x plus 3 goes in parentheses because you're subtracting x plus 3, not just x. Students will often drop the parentheses and do minus x plus 3, and that's wrong. That hoses up the problem. Okay. And that's all over x minus 1 times 2 plus the square root of x plus 3. Well, now this minus sign out front of the left parentheses, that's like a -1, right? It's invisible -1. And so when we distribute the -1 inside the parentheses, -1 times x is -x, and -1 times +3 is -3. Four minus 3 is 1. So we have 1 minus x in the numerator over x minus 1 over 2 plus the square root of x plus 3. Now you might think that we're done, but we're not. Because 1 minus x over x minus 1 actually simplifies to -1. So let me show you why that's true. Okay. Let's multiply x minus 1 by -1. Okay? Which, what we're doing is, let me retrace this. Okay? Let's take the negative of x minus 1, which is the same as -1 times x minus 1. So when I distribute the -1 inside the parentheses, I have -1 times x, which is minus x, and -1 times -1 is +1. Well, minus x plus 1, I can switch the order of that addition. Right, is 1 minus x. So, the negative of x minus 1 is equal to 1 minus x, right? Or -1 times x minus 1 is equal to 1 minus x. Right? Makes it easier. Who is that? Was that you?
Sorry.
Yeah. All right. So you gotta listen to some tunes this morning. So we can replace 1 minus x, right? If I switch the two sides of this equation, right? We have 1 minus x is equal to -1 times x minus 1. Right? I can switch the two sides of the equality. So the numerator over here can be rewritten as -1 times x minus 1. Then we have the denominator, x minus 1 times 2 plus the square root of x plus 3. Do we have a common factor in numerator and denominator? Yeah, x minus 1. So we're left with -1 over 2 plus the square root of x plus 3. And if you want to, you can pull the minus sign in front of the 1 here out in front of the quotient if you want to. Okay? Just to remind you, -1 over 2 is the same as -1/2. Right? You can pull the minus sign out in front of the fraction. Okay? What can x equal in this case? 1, right? Over here in our original expression, x can equal 1, because if x equals 1, we have 1 minus 1 in the denominator, which is 0. So, x can equal 1. Again, you don't have to write this part, x can equal 1. I don't think you have to write it in WebAssign. And you won't have to write it on a quiz for now. I'm just trying to get you thinking about the domain of a function. Okay. Number one, if our function was f of x is equal to this, right? 1 is not in the domain of the function because you would end up dividing by 0, and you can't divide by 0. Okay. Ever. Okay. All right. So now let's do the next one where we rationalize the denominator, and then we'll take our quiz. So in rationalizing the denominator, we got to get rid of the square root in the denominator. So to do that, we multiply top and bottom by the conjugate of the denominator. So we have x plus 4 over square root of x squared plus 9 minus 5. And so the conjugate of the denominator is square root of x squared plus 9 plus 5. So we multiply top and bottom. Square root of x squared plus 9 plus 5 over square root of x squared plus 9 minus 5 times the square root of x squared plus 9 plus 5. Okay? So the denominator is of the form a minus b times a plus b. So this is equal to, the numerator is x plus 4 times the square root of x squared plus 9 plus 5. And the denominator, right, a squared minus b squared. So we have this square root times that square root, right? So we have square root of x squared plus 9 squared minus 5 squared, right? That's our difference of squares in the denominator. Well, the numerator stays the same. X plus 4 times the square root of x squared plus 9 plus 5. Squaring undoes the square root, and we're left with x squared plus 9, and then minus 5 squared, which is 25. Well, x squared plus 9 minus 25 is x squared minus 16. 9 minus 25 is minus 16. And now you can see x squared minus 16 is a difference of squares. It's x squared minus 4 squared. So this is equal to x plus 4 times the square root of x squared plus 9 plus 5. And this factors in the denominator, x plus 4 times x minus 4, right? Because it's a difference of squares. And now you can see x plus 4 is a common factor in the numerator and denominator. And this now simplifies. The square root x squared plus 9 plus 5 over x minus 4. And we have rationalized the denominator. Okay.